This is lesson 3-2, ratios and unit rates. Let's first discuss what a ratio is. It is a comparison of two or more numbers. Any ratio that has more than two numbers compared is called a continued ratio. Ratios can be seen in two ways. Typically, the way we will see ratios is used as a fraction, but you can also use a colon. All ratios must be in simplest form, and they must have the same unit of measure. Here are some examples for you to complete. You should express each ratio in simplest form as a fraction and using a colon. Pause the video at this point to give yourself a chance to try the examples on your own. Let's take a look at 12-4. When we reduce that, it's 3/1 or 3:1. We need to reduce all ratios to simplest form. 8x to 48x would reduce to 1/6 or 1:6. More importantly, for the study of our projects and for your everyday use, we typically use ratios to create rates. In fact, for our project use, we'll be creating unit rates. A unit rate is a rate with a denominator of 1. To find a unit rate, you want to divide one number given by the other. The order of how you divide is going to depend on the rate that's being asked for. For example, if you're told to find the rate in miles per gallon, you would divide the number of miles by the number of gallons. In your project sense, we're going to be finding the cost per some measurement, like, for example, pounds. To find a cost per pound, you would put the money divided by the number of pounds. The difference between ratios and rates is that you can always leave a rate in decimal form. Typically, we are going to want to do that with our project because we're going to be talking about money. You always want to make sure that you include your units, the top unit per the bottom unit. Here are 3 examples of rates that we use in our everyday lives. Miles per hour with speed in a car, miles per gallon in terms of buying a car, because that's important these days with the cost of gas, and of course, for our project sense, price per item. In fact, for the project, when you're comparing unit prices, the units must be the same. You don't want to compare something that's a cost per pound with a cost per ounce. You need to make sure your unit rates are always the same. Here's an example that'll help you with your project. Now, hopefully you're not going to be buying glass cleaner for any of your baking recipes. However, the example still applies. So at Price Chopper, a 21-ounce bottle of Windex brand glass cleaner is $1.50. The store brand glass cleaner bottle is 34 ounces and costs $2.19. Find to the nearest cent the cost per ounce of the Windex bottle. Then, find to the nearest cent the cost per ounce of the store brand bottle. And then, decide which one is a better buy. Remember that to the nearest cent would be 2 decimal places. Pause the video at this point to give yourself a chance to do the example on your own. So to find the cost per ounce of the Windex bottle, we're going to take the cost, $1.50, and divide it by the number of ounces, which is 21. 1.50 divided by 21 gives me approximately 7 cents per ounce. When I take the store brand cleaner, 34 ounces and $2.19, I want to do 2.19 divided by 34, which gives me a cost per ounce of about 6 cents. So which one is a better buy? The one that costs 6 cents per ounce or the one that costs 7 cents per ounce? You have to think logically and with common sense here. Excuse the pun. But we want lower cents per ounce. Therefore, the store brand is a better buy in this situation. If you're having difficulties with this particular lesson or what to do for your project completion, please consult your teacher in class.